implicit differentiation, but second derivatives. So the same stuff we were doing yesterday, but we're going to go down one more level. And these are often, or always set up, so there's a little twist at the ends to allow you to simplify things. Yeah, it's like a suspenseful movie. So let's say I gave you x squared plus y squared equals 25. And the directions would say find d2y over dx2. Don't worry about y12 is by the d and y1's not. It doesn't matter. It just means find the second derivative. So what we're doing is finding the second derivative of this, but to do this, you got x's and y's in there, so we need to do implicit. So if I just start going through implicit for the first derivative, derivative of x squared is 2x. What's the derivative of y squared? 2y, but you took the derivative of y, so it's times dy dx. And then equals 0, because the derivative of 25 is 0. And then I'm going to solve this for dy dx, so 2y times dy dx equals negative 2x. I divide both sides by 2y. Those cancel. And typically, I would just tell you, like, leave it as negative 2x over 2y. There's no reason to simplify it. You might screw up. How you'd screw up canceling 2's, I'm not sure, but I imagine some people could find a way. Hopefully none of you guys. But in this case, I'm going to cross those out because I have to keep going. So I'm going to write it as negative x over y. And if I have to keep going, I want my next steps to be as easy as possible, right? So now I'm going to take the derivative of this. Well, first of all, other questions on the first derivative. That should be like just what we've been doing. Now I got to take the derivative of that. So you could use quotient. You could bring it up and use chain. I'm going to do quotient. Let's look and see how that goes. So the derivative of the left-hand side, the derivative of dy dx is the d2y over dx2. So the derivative of this gets you the second derivative. On the right-hand side, it's quotient rule. So it's the bottom times the derivative of the top. What's the derivative of the top? Negative 1. Minus the top times the derivative of the bottom. What's the derivative of the bottom? Wait, hold on. Did I mess something up? Okay, what's the derivative of the bottom? Is that what you're trying to tell me? 1, but it's dy dx, right? Okay. Is that what you guys were saying?
Yes.
Okay. You scared me. I thought it was something wrong. Alright, over the bottom squared. So over y squared. And then I'm going to do this, and I want you to tell me where I got it from. What's that noise? So what did I just do? One thing I did was I just took the negative times the negative and was like, okay, that's a positive. That's easy. Where did I get the negative? How did I replace dy over dx with negative x over y?
Because we know
Jonah Priest.
Because we know that dy over dx equals negative x over y, so you can just substitute it.
I figured out what dy over dx is over here, right? So instead of putting, because I'm not going to be able to simplify this with the dy dx in it, that doesn't really help me, so I'm replacing dy dx with what I know it's equal to. So all I did was plug in, now it's x and y instead of dy over dx. Now, I have 3 terms in this problem. One there, one there, and one there. And this term is really just negative x squared over y. Do you agree with that?
Yes.
So I just multiply those two x's together and get negative x squared over y. So I got 3 terms. I cannot have a fraction on top of a fraction. So I need to get rid of the fact that there's a fraction over a fraction. So what can I multiply this term by to get rid of, so it's not a fraction? Multiply by y. So I'm going to multiply this by y, like y over 1. But if I multiply that, if I multiply that term by y over 1, I've got to multiply this term by y over 1, and I've got to multiply this term by y over 1. So then what I end up with, what's y times negative y? Negative y squared. What's negative x squared over y times y? Negative x squared. Because the y's are canceled. At the bottom I have y to the third, right? I have this d2y over dx squared equals that. That is not an incorrect answer. It's not really complete, and these will be multiple choice questions, and you'll have to kind of match up with what they did. And what they would do here, I want you to take a minute and see if you can figure out exactly what they did. Because they would say that's your answer. So what's going on there? What did they do?
They plugged in y because it was. Oh, they just plugged in the values. It was the same as the x squared plus y squared. They just made it negative because it was negative y squared.
Good. So up here in the very original question, they told me x squared plus y squared is 25. If that's true, do you agree that negative x squared minus y squared equals negative 25?
Sure.
And then if that's true, can't I replace this with 25 or with negative 25? So that's what they're doing, and they want you to be able to take that last step and say, okay, I know I can replace that and plug in the number from the original question. So the first derivative is the same, that's just normal. Second derivative gets goofy. You got this dy dx in here that you have to replace, so you're kind of replacing twice. You're replacing what the derivative is there, and then when you get to the end, you're going to be able to go back into your original question and replace something else. Questions in there anywhere? What doesn't make sense? Where did this come from? What in God's name is happening here? Is that what you really? If that's what you feel, I want you to tell me. Can I erase it? Were you still right? Okay. So this one's extremely similar. I mean, I understand that, but I want you to try it anyways. So x squared plus y squared equals, let's say 49. I want you to find the second derivative. Okay, so the first derivative, it's the same as the last one, so 2x plus 2y times dy dx equals 0. So for this part, it doesn't even matter what that number is because it goes to 0 right away. And I'm just going to jump to dy dx equals negative x over y. Are we good with that? So then I got to take the derivative of that. Okay, so quotient rule. So the second derivative is, again, the bottom times the derivative of the top minus the top times the derivative of the bottom, which is dy dx, over the bottom squared. But instead of dy dx, what am I going to put? Negative x over y. So if I just kind of rewrite that, I'll have negative y plus, because negative negative, this is like x over 1, so going across the top gives me x squared, going across the bottom gives me y over y squared. Then you're not allowed to have a fraction on top of another fraction. So I'm going to multiply this term by y so that those cancel. But that means I have to multiply every term by y, because I'm fair. That gives me negative y squared. What did I miss?
should be negative.
Oh, it should be there's 3 negatives, aren't there? So 1, 2, 3. So there's still 1 left. So this should be minus. Minus x squared over y to the third, and then I know that x squared plus y squared is 49. So if I make everything negative, this would be negative 49 over y to the third. How many have it, first of all? How many understand the process, like you know what you're doing? I just copying. I mean, are there questions I can answer? Yeah.
Not really questions, but just
Comments, concerns?
so I don't know.
What?
But yeah, I got the same. Like, when you give me a different equation,
Yeah, we're gonna do a different one right now.
Yeah, I'm
See
gonna
how.
totally screw up the process.
Well, let's try it. See if you do. Any questions on this specific one? Taylor, I remember on the worksheet number 4, I think, was pretty much just like one of these. Can you read me any other 1 through 5? What number is it?
Number 3.
All right, we're doing number 3 on your worksheet.
5x plus 2y squared equals 1.
You guys want to try it or want me to do it?
I know.
Okay, try it. Alright, so first derivative would be 5 plus 4y times dy dx equals 0. So then 4y dy dx equals negative 5. And dy dx would equal negative 5 over 4y. Then I gotta take the derivative of that. So the second derivative over here, quotient rule, so the bottom times the derivative of the top, but what's that? Which is 0, so that's nice, because this part just will go away. Minus the top times the derivative of the bottom. That's not. Oh, good call. Minus the top, which is negative 5, over the derivative of the bottom. What's the derivative of the bottom? 4 dy dx, right? All over the bottom squared, so all over 4y squared. Okay, so that's gone. We got 2 negative signs, makes it a positive for now. So it's 20 times dy dx, but what's dy dx? It's negative 5 over 4y. All over 4y squared. So how many terms do I have in this problem? 2. Because like the giant fraction bar separates them 2. So there's nothing separated plus or minus wise, because that's the multiplication, that's the multiplication. But you get 1 term on top, 1 term on the bottom. You have a fraction on top of a fraction up here, which we're not allowed to have. So I'm going to multiply, let me write this out first. This would be like negative 100 over 4y. Over 4y squared, because that's like 20 over 1. With me there? Then I need to get rid of this fraction, so what am I going to multiply the top by 4y to make those cancel. I then need to multiply the bottom by 4y also, so I end up with negative 100 on top, and then how many 4y's do I have on the bottom? So I have 4y to the third. And then what do I plug back in from the beginning? I can't. No. So sometimes there will be, sometimes there won't be. I wanted to show you a situation where there was one, but I can't look at this and, I mean, nothing in my answer matches up with my original question, right? So that'd be all you can do. Questions there? Somebody had that? Yeah.
It should be 100 because that 20 is also negative. It's a negative 5 over 4y.
But I've got it's a minus that too,
It's a
though.
minus.
So you got a minus and a negative, which cancel. And then the dy dx brings in a
never
third
mind.
negative. Good? Okay. Well, no, you have the answers up in front of you, am I right?
Yeah, you are right.
Okay. like 6 through 10?
Eight.
Did you say a random number?
Yeah.
I mean, are you looking at the worksheet? I want to do what I homework.
Seven.
She said 7. Repeat number 7.
Sorry.
Number 7. 3x to the third.
Hold on, my pen's tired or something. Every time this happens, I think of Mr. Packard now. He's like, see, you're not supposed to use technology. It's stupid.
It's still recording.
It's not, though, is it?
I was gonna.
Oh, it doesn't? That's okay. I wasn't sure.
Ask.
Alright, can you read to me again?
3x to the third.
Okay.
Plus 4y squared equals 1
And then it should give you a point with these two, right?
at negative 1, 1.
Okay. So, they're asking for the second derivative at negative 1, 1. So we're going to do the two derivatives, and then we're going to plug in. Remember we talked about this before. If you're just plugging in, is there any benefit to simplifying first? Not really, because you might make your life easier because it was simpler to plug into, but you might screw up the simplifying and take more time. That's what I'm worried about. So I'm not going to do like the plug back in thing. I'm just going to plug in kind of as we go. So you'll see what I mean. So the first derivative will be 9x squared plus 8y times dy dx equals 0. So I'm just going to jump to this. So the next thing I would do would be subtract 9x squared from both sides and then divide by 8y. Agree? Okay. Second derivative would be quotient rule. So d2y over dx2 equals, I want the bottom, times the derivative of the top, which is just negative 18x, minus the top, times the derivative of the bottom, which is 8, times dy dx, all over bottom squared. And I do not want to simplify that. I don't want to multiply 8 times 18. I don't want to figure out the dy dx and like get rid of the fraction over fraction. So, way around it. Let's plug in right now. You know, your x value is negative 1, your y value is 1. So, 8 times y times negative 18 times negative 1 minus negative 9 times negative 1 squared times 8 times, and this is like the super shortcut. What am I going to put in instead of dy over dx? I'm not going to put the variables in. I'm not even going to put the, because if I put the variables there, what's the next thing I have to do? Like plug in the numbers, right? So why don't we just plug in the numbers over here? And what do I get? Negative 9 over 8, right? So let's just put negative 9 over 8 here. And then these problems are always set up so that when you do that, something will cancel out and you won't have to deal with the fraction over fraction anymore. So right here, don't those just go away? You got 8 on top, 8 on the bottom. And then I don't have to deal with getting rid of the fraction over fraction. On the bottom, it's 8 times 1 squared. And now we just kind of do a bunch of just mental math, I guess. But I got rid of the variables, which makes my life a lot easier, I think. 8 times negative 18. What's 8 times 10? 80. What's 8 times 8? two negatives here. So this is 144 minus negative 1 squared is 1. Negative 9 times that is negative 9. Negative 9 times negative. So, okay. This is a positive 1 after I square it. And then I've got 1, 2, 3 negatives. So this will be minus. It'll be minus 81. Because 9 times 9. The bottom 8 squared is 64. So this comes out to 63/64. Yeah, am I right? Are we right?
What was the answer?
63 over 64.
Yep.
Questions on that process? What I'm doing there? I think I can answer. Yeah. What?
That 80, does that square the whole thing?
This?
Yeah.
That was from 9x squared, so you just square the x. Remember you do exponents before you do multiplication?
Oh, I forgot about the other 9. The 9 over 8.
So, okay, so you had to square.